So for my EECS 495 project, I did a sentiment analysis pipeline using some Twitter data. So what I did was, first what I did, I looked up sentiment analysis and I kind of got a basic background. I looked up some papers and kind of got an idea of like what features were in use and what to look for and what I needed to know. And this kind of actually guided my work in terms of stuff that I tested, and so I'll go more in depth of what I tested later. But first, I looked and I found a way to get the Twitter data with the sentiments with the Twitty client. I didn't obviously do it myself. I looked online and someone was able to tell me how to do it. I have all these helper functions that deal with getting the tweet and parsing the data to get it in the proper form. That way, and some of these functions are helper functions to actually even test out things like we can generalize the mentions. So what that would do is that would take out the actual person that is being mentioned, and it would just say this is a mention. Everywhere, so it's all the same. And so I have functions like that. We also have the pipelinized features and the pipelinized functions, just the pipelinized function. And what that does, it allows us to add custom functions into the pipeline if we pipelinize them, because they have to be in a certain form first using the function transformer for them to be able to use in the pipeline. So we need this extra wrapper function to allow them to be added in there. And we also have the train test that does a split and also gives some information on how the classification went after we actually run it and how each run goes. So next, we go into the setup and data fetching. And here, I just run the fetch data, and so it gets the posts. Some posts won't be got just because some posts get deleted, but that's okay. We still get most of the posts, or enough posts that we can still do testing. I also set up a stemmer, and we use a count vectorizer. And there's also actually a special tweet tokenizer, which will do certain things, and specifically for tweets like dealing with hashtags and stuff like that wouldn't be, at least in the standard tokenizer, or is more common in the tweets, that make it nicer. So that's something else that I use. And so we use the tweet tokenizer. Right now we have the preserve case false, so that means everything gets put to lowercase, but we don't reduce the length. And so what that does is anything that repeats repeatedly, character that's repeated more than 3 times would be reduced to 3 times. But what I did later is I actually do a grid search to look for the optimal parameters, and it showed that using that, having it on was actually worse. So it said to have it as false. And so next, we set up the count vectorizer with that tokenizer, the tweet tokenizer, and then we have the analyzer as the stem words analyzer. And so that will basically, it takes the words in their full forms and will just put them into their stems. So that way we get the most basic words. Now this can be good or bad, it varies. But we also test this out, and actually one of the papers that I look at actually analyze how that works out. So next, I actually set up the pipeline and we run it through the Twitter data using our train test evaluate. And you can see that we get 60% accuracy, which the null accuracy is 45.88. So we're improving. We're better than the null accuracy. I've actually had it do worse. Usually without any of changes from like the default pipeline, kind of without like using things like mutual information classification, I can only get like 52 or 54. So it improves like 5% when you add in things like feature selection, and then you actually follow along with the optimal parameters. And so that's actually what we do next. I actually go through grid search to search for the best parameters in the set of parameters, such as the n-gram ratings, the stop words that we should recognize, or whether we should or should not recognize them. And then what data document frequency should we actually care about words, and like what's the maximum document frequency. And so we can run through that, and this actually takes a bit longer because it's running through all the combinations, and it's not very short. So it can take, I think, like maybe 10 minutes to run. But it comes back and it will tell you what the best settings are with the use tokenizer and what parameters. So that's kind of what I did, and like I said, I kind of tested out some of the ideas in here in this paper, and this paper kind of analyzed the parameters that I was using, such as the ngrim and the stemming, using stop words, the feature length, to see which one had the best. And what my grid search actually came up with very much aligned with what this paper came up, or it was very similar to what it said. So it wasn't as high a percentage accuracy, and that might be because of the amount of data I have, but it was similar in the level in terms of which ones did well and which ones didn't do well. So, all right.